Hello, everyone. I think we can get started while we wait. Perhaps a few more people may join in. Welcome again to everyone. I hope I am audible. I think, can you hear me?
Yes, Kaushik, we can hear you.
Okay, great. I know we have participants from all over the world. So, good morning, good afternoon, and good evening, wherever you are. I hope everyone is keeping safe as we go into the year end. And I'm going to first request Ajinkya to just walk us through a few quick housekeeping issues, and then we'll start the webinar. Ajinkya, over to you.
Thank you, Kaushik. Thank you, everyone, for joining us. A few instructions for the webinar before we start. So all participants will be on mute except the panelists until the Q&A session. And participants can ask questions during the presentation by typing them in the Q&A section below. At the end of the webinar, there is a participant poll. We request everyone to participate in it. And webinar slides have been published online, so we'll be sharing with you the link. And webinar is being recorded and will be published online by next week. And we have disabled everyone's video to minimize lag in audio and the slides. Over to you, Kaushik.
Thanks, Ajinkya. If you can move to the next slide. Great. So again, welcome. This is Kaushik Gala here. I am with FlightBase. Also along with me on the panel today are David Ultimate and Joseph Waldron. I will introduce all three of us. So I have over 20 years of experience doing technology commercialization, business development, management consulting, and early stage investments. At FlightBase, I lead our revenue generation, especially with emphasis on FlightWare, which is our solution for deploying inventory drones in large warehouses and distribution centers. With me is David. David is the president at Altamir Consulting in Dallas, Texas. He has over 25 years of professional experience in engineering, research, manufacturing, supply chain management, and IT. And his diverse experience spans aerospace, medical devices, software development, and many other industries. He's worked at nearly all functional levels and areas. Also, we have Joe. He's the product integration director at RawView in the UK. He has over 12 years of professional experience in engineering, industrial automation, and of course, unmanned aerial vehicles. At RawView, he specializes in helping enterprise customers adopt commercial drone solutions and seamlessly integrate them into their business operations. And of course, we will hear more from David and Joe later today. Next slide, please. So today's webinar, of course, is being hosted by FlightBase. A very quick introduction to our company. We are a US-based software startup, and we help enterprises automate and scale their drone operations. Over the years, what we have done is built an intelligent automation platform. You can think of it like Android or Windows, but for commercial drones. And on top of this platform, we have built a variety of drone solutions for outdoors as well as indoors. For outdoors, for example, we have a solution called Flight Now, which can be used for security, surveillance, public safety, and so on. We also have solutions for wind turbine inspection, asset inspection, and delivery. And today's focus is going to be on our indoor solution for warehouse inventory. With that, next slide, please. So this is a quick outline. We'll start off with some context setting around warehouse automation, which is the theme of today's webinar. We will request David to talk about very narrow aisles and what's special about them, where are the advantages to use. Joe will talk about drones and especially in the inventory context. We will have a quick summary of the FlightWare solution, and then we'll open up for questions. And again, as Ajinkya said, feel free to type your questions as we speak as well. And finally, we have a quick participant poll to get your feedback because we hope to do many more webinars in the future as well. Next slide, please. So the context again for today's webinar is warehouse automation, which is probably one of the most defining trends in the supply chain industry. And especially this year, we have seen a lot of acceleration in automation because of restrictions on human presence in closed facilities like warehouses. Whether it is goods to person robots or whether it is automated storage and retrieval systems, we are seeing large warehouses and distribution centers invest millions of dollars in each facility so that they can automate their inventory operations. And of course, Inventory counting is a relatively smaller use case in the overall warehouse context, but it is also the one most easily and quickly amenable to automation because the upfront capital investment required is relatively small. The return on investment, in fact, for inventory counting automation can be within months instead of 5 to 10 years for the more expensive systems. And of course, automated inventory counts have been explored before using RFID tags, ground robots, even fixed cameras. But none of them have been adopted so far on a large scale because of the long payback periods and the complexity of deployment. So this is where drones come in, where the 3D space can be used to scan inventory, and that's what we'll cover today. Handing it over to David to talk about very narrow aisles.
Hi, everyone. Pleasure to be here. Thanks to FlightBase for inviting me. I just want to give you some background on what very narrow aisles are and what they're good for and what their implications are for the operation as a whole, and particularly with respect to inventory counting, since that's the focus of today's webinar. So the concept of a very narrow aisle is really a strategy to improve the efficiency of a warehouse. So what we're talking about are aisles that tend to be anywhere from 5 to 9 feet wide, which is the traditional aisle is like 9 feet. So we're talking about 5 to 9 feet, and the most common aisle width is 6 feet. So it's just enough to get a forklift truck in between. And the idea here is that you can bring the racks closer together, and then you can go up vertically a little bit higher than you normally do so, and then the volumetric efficiency of the warehouse is really increased. So this is great in urban areas that where real estate is relatively expensive, so you can really maximize the utility of the warehouse. Typically, in a very narrow aisle configuration, you're only able to access pallets or case reserve stock that's one level deep. So you have immediate access to all the products in your warehouse. And because you've reduced the width of the aisle, you can increase the packing density of product by 40 to 50%. So it's pretty significant in terms of an efficiency improvement. Now, one of the requirements of a very narrow aisle is, because you're constrained by space, is that you need special equipment. And so if you see there in the picture, you see a specialized forklift truck, and the trucks that are designed to operate in very narrow aisles have a special articulated turret in the front so that the forks can be rotated 90 degrees in either direction. So in a traditional warehouse, the forklift, you have to drive the truck perpendicular to the racks to insert your forks and pull out the product. There's not enough room to do that in a very narrow aisle. So you will need a special truck to handle that. And the cost can be quite high. It's not uncommon to pay over $100,000 for one of these trucks. So it's a significant investment. And because you're constrained by space and the narrow aisle, you can't immediately load product from the forklift truck onto another vehicle. So that's a limitation of this kind of configuration. You also have to have special training for the special equipment. And because you're constrained on space, there's a high probability of accidents. And in two ways. One is with people working in the warehouse, so warehouse workers. These trucks operate typically on buried wires in the concrete so that they're guided by the buried wire and they'll drive themselves automatically in a straight line. So there's not enough room on either side for another vehicle or workers to pass around. So you really have to close off these spaces from workers. But in addition to worker safety, there's also the prospect for accidents that have to do with product that is sticking out of the pallet locations. So although the trucks drive very carefully in a straight line automatically because of the guided wires, there's a prospect of perhaps some pallet stock poking out into the aisle and getting snagged on the truck. So there's a higher probability of accidents because of the space constraints. So 20,000 workers are injured in forklift accidents each year, and each of those accidents can cost anywhere from $38,000 to $150,000 for each company and each incident. So it's the worker safety issue is a significant one. So let's talk about what the implications are for the very narrow aisles with respect to inventory counts. So first of all, I want to say that when you do inventory counting, there's two classes of inventory counts. You can do a full wall-to-wall count, which is counting all of the stock in your building, or you can do cycle counts, which is a statistical method for counting a small number, a statistically significant sample of SKUs or part numbers, and you do a little bit at a time, and you have a daily or weekly program. So if you operate a large distribution facility, doing a full wall-to-wall inventory just doesn't make sense because you just have too much product. So you naturally have to do cycle counts. Smaller manufacturers, folks that have smaller facilities and have problems with their accounting may be compelled to do full wall-to-walls, but it's very, very tedious. In either case, the advantage or the benefits of doing a physical count is that you are exercising an inventory control that allows you to ensure that you have material and product available in sufficient quantities. And by doing so, you're able to help the accounting department correctly evaluate the inventory. The physical count can also reveal theft or shrinkage in the warehouse of products. And in some cases, you may have some regulatory requirements or customer service level agreements where that heightened level of inventory control is necessary. Now, how do you perform the counts? If you perform them manually, then bear in mind that you may require more of those expensive forklift trucks than you would ordinarily. Because if you have a large distribution facility and you have a good cycle counting routine, then it means that you're always engaged in a physical count somewhere in the warehouse. And to do the count properly, you'll have to have a forklift truck, one of the special forklift trucks that is dedicated to doing the counting of that particular area of the warehouse at that particular time. So if you're in a large facility, it means that somewhere there is always a cycle count being performed, which means you have to dedicate capital equipment to it. Additionally, because you have to close off parts of the warehouse where you're doing the physical counting, it can be time consuming because you're doing it manually. And because it's time consuming, depending on your system, it's possible that you may run into timing errors because of the time it takes to perform the physical counts and introduce corrections, adjustments into the system. It may lead to timing errors in the accounting. And because it's manual, these inventory counts are susceptible to human errors and a risk of injury. So let me pass it off to Joseph, and he'll speak a little bit more about the application of drones to
Thanks
inventory
very much, David.
counting.
Hi, everyone. Absolute pleasure to be with you today. So as David mentioned, I'm going to give you a brief insight to the data collection tool, also known as the drone. Next slide, please. So here's just a quick overview of the main drone types that are used across different applications. So over on the top left-hand side of the slide, you can see what we class as a multi-rotor drone. This is what most people picture when they think of a modern drone. They're actually the most commonly used type, and that's predominantly due to their maneuverability and also their ability to work in confined spaces. Over on the top right, we have a fixed wing drone. So this is what you might consider to be sort of closely matched to an aeroplane. So this is typically used to survey large areas of land. Over on the bottom left, we've got a single rotor. So as you can see from the image, this closely resembles a helicopter. So this is really only used for a handful of bespoke applications. It's capable of holding quite heavy payloads and also has good levels of flight efficiency as well. And then the final platform we're looking at here on the bottom right-hand side is what we class as a hybrid VTOL. VTOL being an acronym for vertical takeoff and landing. So it's similar, as you can see from the image, very similar in design to a fixed wing drone. But unlike a fixed wing drone, it also has the ability to take off and land in relatively confined spaces. However, for the purpose of this webinar and the conversation we're having today, that being for indoor applications of drones, the most suitable type that we're going to be talking about is the multi-rotor solution. Next slide, please. So even if you've had no hands-on experience of drones, you'll probably know enough to link their primary use cases if we can actually have the ability to remove the need for a drone pilot. Having said that, going indoors with a fully autonomous drone does give us a few technical challenges. So firstly, just like on a commercial airliner, GPS technology actually makes it possible for drones to fly themselves from A to B without a pilot actually doing any manual flying. Now, that's all well and good when the drone's working outside and has a clear view of the sky. But what happens when we want to fly, when we want them to fly themselves in and around very narrow aisles in a warehouse, for example? Well, clearly we're going to lose reliable GPS connectivity. So we need to be able to find an alternative method that tells the drone where it is now and where it needs to go next. And it needs to be able to do all of that in a safe and precise way. Following on from that, we know that an autonomous drone is one that flies itself without a human at the controls. So this means that they need to work in a way that replicates, or even better still, improves what a skilled drone pilot would be doing. Not only does it need to maintain stability when it's actually in flight, it also needs to be able to detect and avoid both stationary and moving obstacles without any human input whatsoever. Clearly, it goes without saying this is massively important when you have multiple drones flying in and around VNAs. Finally, by their very nature, VNAs don't offer a huge amount of space between the racks. So this means that the drones need to be small, nimble, and lightweight. Next slide, please, Kaushik. So we've touched on a few of these already, but when it comes to using drones for inventory count specifically, there are some absolute must-haves for the solution to be considered feasible. So firstly, the drones must be able to fly precisely and completely autonomously, even without access to GPS. Even the most skilled drone pilot wouldn't actually be able to manually fly with enough precision to scan what could be tens of thousands of barcodes in a warehouse. Secondly, the drones must be able to enter and safely navigate up and down a very narrow aisle, or indeed very narrow aisles, plural. Obviously, the whole objective of this is to be completely autonomous. So we don't want people having to manually move drones in and out of aisles, for example. Next, the drones need to take off, land, and recharge automatically. Again, it defeats the object of the exercise if we're going to be reliant on humans doing things like swapping out and charging batteries. So this also needs to be completely automated. Next, the drones must be able to sense and avoid obstacles on their own, whether those obstacles are static or in many cases actually moving. The drones need to have the ability to avoid making contact. Number 5, so the whole system needs to operate with ultra high reliability. Now this is a crucial one really. So after all, we are actually taking humans away from the task of inventory counting. So it goes without saying that the system and its component parts must be highly reliable. And finally, as the technology continues to evolve and improve, so for example, things like battery life of the drones themselves, those benefits need to be easily transferred to a warehouse's operation. Next slide, please. So the intent here with this graphic is really to show you what I consider to be the ideal workflow for aerial inventory scans. So step 1, you can see over on the right hand side, the drones will automatically launch from their home points, ready to start their mission. Next, they need to be able to enter the aisle, then navigate to each rack location, scan the product barcodes within that location, then send that data back to the ground station, which you can see down at point 5 in the bottom left-hand side. Step 3, after the mission, the drones need to be able to take themselves essentially back to the home point to be recharged and readied for the next mission. And finally, we need to be able to see a report of all of the scanned barcodes, and that ideally would be displayed in a nice user-friendly dashboard. Next slide, please. So following on from that sort of ideal workflow, if we are going to unlock the full potential of inventory counting drones, we need to be sure that the solution is truly end-to-end. So firstly, it's important that we minimize any impact to existing warehouse infrastructure. An example of this is to ensure the system can scan different product labels and compare scanned information with what's logged in different warehouse management systems. Secondly, rather than only being an autonomous barcode scanning solution, impressive though that is, we should also try to make use of other opportunities that drone technology presents. So, for example, we know that modern drones tend to have high quality cameras. So why not use them to produce date and location stamped images and perhaps even video footage that can be used for internal and statutory audits? Also, if we're completely autonomous and we're integrated with the warehouse's WMS, wouldn't it be great to also send the drones direct to bin locations that the WMS shows as being empty, so that we can actually confirm that those locations are indeed empty? Or maybe even send those drones to locations that have recently had new physical inventory allocated to them. And in that way, we can check for put away errors, for example. Next, it goes without saying that any solution needs to operate safely and be able to react to unforeseen events. So this picks up on what I was saying about the sense and avoid of obstacles. And the final point here, it needs to have the ability to scale across extremely large facilities and across an organization's entire warehouse portfolio. So on that note, I'll hand over to Kaushik, who I think is going to talk you a bit more about the FlightWare solution.
Yep, thank you, Joe. So yes, before I talk a bit more about FlightWare, just wanted to remind everyone you can type in your questions in the Q&A window. FlightWare, of course, is FlightBase's solution for deploying a fleet of autonomous drones inside warehouses to scan inventory. One of the most important things we have learned after visiting maybe 100 warehouses in the last year or so is the importance of reliability. And given the history of FlightBase, where we built an intelligent automation platform that is agnostic to drone hardware, we were able to use off-the-shelf drones which are very reliable and make them intelligent enough to fly inside warehouses even without GPS. So of course, you would want a fully autonomous solution to be extremely easy to use. And really the only human involvement required in FlightWare today is for an operator to use this dashboard to plan missions and to observe the data. And of course, even this can be automated away by having a WMS automatically plan and run these missions. But even so, the dashboard itself is very, very easy to use, very intuitive. And the idea is that you would want your existing warehouse associate to be able to seamlessly transition to aerial inventory counts. Everything is fully automated because one of the feedback we received consistently from customers was that they wanted to deploy drones during weekends or in the night or in between shifts when there's nobody in the warehouse. And so everything has to be fully autonomous, not only the navigation, but also the takeoff, landing, charging, and of course the barcode scans. And of course, with artificial intelligence and machine learning technologies available, there's a lot more intelligence that can be done in terms of inventory counts, not only reading barcodes, QR codes, and printed alphanumeric labels, but eventually even automatically counting individual items in rack storage or even bulk storage. The other thing that came out of our customer conversations was the importance of reliability. And so having the solution to be enterprise grade, because a lot of valuable inventory information is being collected by these drones. And finally, making sure that this data is being securely stored, especially say you have a third party logistics company that's deploying these drones. They're very sensitive about the inventory data going outside the facility. So by having FlightWare architected as an on-premise solution, we make sure that all the data is available locally and safe. And of course, there is always an option to push it on a private cloud instance if required. And finally, all this data is being collected so that we can analyze it and so we can derive real-time insights. And so the two components that enable it is a centralized control station where a warehouse inventory stakeholder can oversee the operations and the data. And this can be done in the computers within the warehouse, or it can even be done remotely from a corporate headquarters. And of course, the last but the most important piece, which is to be able to seamlessly interface with a warehouse management system or a ERP system so that the data collected by the drone and from the WMS can be compared, and those variances can be addressed by looking first at the images and then if required sending a person to those locations. And having said all of this, drones remain a relatively new technology, so there has to be a risk managed way to deploy drones in these facilities without disrupting inventory operations. And the way at FlightWare we have seen this work is starting off with a very simple checklist to both make sure that it is technically feasible to fly drones, but also to build a business case for it and show that yes, it makes commercial sense to adopt drones. Once the feasibility is confirmed, we move on to a on-site pilot, which is generally for a few days, where the entire end-to-end solution is demonstrated in a few aisles, not only the navigation, but also the WMS integration. And finally, the idea would be to go live with FlightWare at that facility and more facilities, and actually stop doing manual inventory counts and instead do them using drones. And we see that many customers, especially the ones which have either large facilities or the ones that count frequently their inventory, can in fact realize a return on their investment in less than a year. So the business value, of course, comes directly from the cost and time savings, not only the people, but also these expensive swing reach trucks in VNAs and the time, but also intangible benefits like being able to redeploy these human resources onto more productive tasks. to avoid safety risks associated with going into tall racks and narrow aisles. And then now that we have this rich image and video data, being able to derive more rich insights and also having the data in a format that's easy for audits. And like Joe said, technology is at a certain stage today, but we have seen hardware and software both rapidly mature. So it won't be too long before we can deploy the same fleet of drones, for example, over bulk storage, not just rack storage. And perhaps even soon be able to count individual number of items in a partial or a broken pallet, and perhaps integrate RFID tags and even look at multi-deep storage instead of just focusing on one deep pallets right now. So, this experience, of course, has been gained by testing our solution at various facilities. When it comes to VNAs, we have tested this at one facility which had 6 feet wide VNAs and one deep pallets kept in those, and also two other facilities where the aisle widths were 5 feet, and instead of full pallets, there were individual boxes or cases kept one deep. And you can imagine that in that case, the ROI is probably of the order of a few months, because now instead of in one location, a person having to scan 20 barcodes, a drone can scan all of those 20 in one shot. So that's where we see the business value come from the FlytWare drones being used for inventory scan. Thank you again, everyone, for taking your time out. We know that there are a lot of webinars going on, so appreciate your taking interest in FlytWare. And thank you, David and Joe, for your time in sharing your thoughts on VNAs and on how drones can be used for warehouse inventory. Any last comments, David or Joe?
No, thank you, Kaushik. Really appreciate FlightBase inviting me, and happy to be here.
Thanks.
Yeah, likewise.
Great. Thank you, everyone, again. And have a good rest of the day, and early Happy New Year to everyone. Bye-bye.